Good morning. Appreciate the opportunity to come up here and spend a few minutes talking about something that is near and dear to my heart. It's been much of the last several years dealing with this or working with this particular topic. I mean, I don't know if that many of y'all realize that smart work zones have actually been at least discussed in about 20 years. We've had 20 years of development. Really hadn't seen a lot of movement in this area until probably 6-7 years ago, and that was because we were trying to figure out, or the vendors were trying to figure out, how to solve some of the fundamental technical issues. We've reached that point. Have now several system components that are very robust, that do a good job, and can help us manage and mitigate traffic impacts in our work zones through the use of these systems. About 3-4 years ago, Federal Highways decided that the technology wasn't mature enough, started its initiative to encourage the use of this technology on projects as a tool to manage impacts through that Everyday Counts initiative. What I want to do today is sort of go through I guess I'll call it a Smart Work Zone 101, a primer about the technology, what's capable, what you're trying to achieve, what things to think about as y'all, as I know many of y'all are currently looking at or have deployed systems here in Texas. Texas is actually held up, nationally as one of those lead states in this area. Have done a lot of good things in this area. A lot of the data, the information that others are using about trying to estimate the benefits that may be achieved through this technology is coming from Texas. So as a start, I think everybody's probably pretty familiar with this, but smart work zone systems really consist of 4 main components. There's something that measures travel or traffic in some way. It can be spot sensors, and those can be simple K-band radar. They can be the Wavetronics side fire. They can be point-to-point travel measures. It can even be things are now moving in that, even in the third-party data being bought from the private sector. But something that measures traffic around the work zone. There's some method of communicating the data from the field, to a someplace that's going to process that data. It used to be we had wires almost way back ago, but now we got wireless communication, cellular, most common. It used to be a processor someplace on the system on site. Now we've got it being sent up in through the Internet of Things and being processed remotely and coming back down. So we have the software component. And then ultimately the key thing is we have something that then uses that information to do something, and it can be equipment. Most commonly, you're looking at portable changeable message signs, or even dynamic permanent signs. May even be people. I probably should have people in here that's going to use whatever information that you've turned that data into to make either provide information to the users, make traffic management, work zone management decisions. So that's what a work zone system is, right? So pretty simple. The key thing, though, is to keep in mind that this is a tool, or that we're using to try to generate some type of improvement or some benefits. It could be to the traveling public. That's most commonly what we're trying to do. But in some cases, we're actually trying to improve the safety of the work crews on site in some fashion, and ultimately by doing that, there also may be improvements that the agency itself receives from that. They may be primary, directly. That's the reason we're putting things in there, or it could be secondary. They result because we're able to achieve some benefits elsewhere, and the agency itself, benefits from that improvement as well. So. What we think about, well, what I would guess if you walk away with one key slide out of this is to recognize that, yeah, we put these systems out for a reason. That we could get caught up in talking the details about does the system designs and those kinds of details, but ultimately we're trying to achieve some sort of a benefit by deploying these. And I really break into 4 basic categories, and I bring this up as you go through and deciding when and where and if to deploy. You should always take that back to the concept of, well, what am I trying to achieve in terms of a benefit? Am I trying to ultimately, improve safety? We say that a lot, but what does that mean? We really are trying to get fewer crashes, less severe crashes, that kind of thing. Maybe we can't measure it really well, or haven't been able to so far. We use surrogates of indicators that we think relate to that aspect of the system. But that's ultimately why we're trying what we're trying to do there. So safety, mobility, predominantly the reduction in delay and congestion. It may be, improving travel time reliability, as David was talking about previously. Customer satisfaction. There are instances where systems are deployed. We know we can't affect, mobility a whole lot, but if we give you advanced information about the fact that you're going to be experiencing delays, that has a positive impact on customer satisfaction or reducing customer dissatisfaction. We have had or been involved or out on several projects where the significant delays resulted. You talk to the motorist afterwards, and obviously all of them are really hacked off because they didn't know about it. And the most common one is it's like, man, I had to go to the bathroom for hours and I didn't know that. And if I'd have known that ahead of time, I could have pulled off. Or my kids were hungry, the same kind of issues. So there is a customer satisfaction component to this. A little harder to measure and quantify economically, but still a very important aspect of these systems. And the fourth one, it tends to be more secondary or indirect, but still is a significant one, is by improving the way that the traffic moves in and around these work zones. We have less impacts to the contractor as they try to complete whatever tasks they are, and so productivity, efficiencies are also positively affected by these systems. And so, the key thing that we're going to go through in the next few slides here is I use the term smart work zone systems. I know most everybody does, and as if it's a thing. I'm going to put out a smart work zone system. But we really need to think beyond that because it's really smart work zones can do a lot of different things, and we'll go through several of them right here, among the common ones. And so when you talk about smart work zones, you really should talk about smart work zone functions. And those functions relate specifically to certain types of benefits. Some are deployed predominantly to deal with safety impacts. Others are designed to provide predominantly customer satisfaction or reduce the dissatisfaction. Some are trying to predominantly address mobility. They can have those secondary or affect those other metrics as well in a secondary manner, but they have one or more primary functions, and that's what you need to focus on. It's not a smart work zone system. What smart work zone function do I need to deploy? And you can design a system, and you can talk to there's several vendors and manufacturers that have really good systems, and you can kind of plug and play and create hybrid systems that do more than one of these functions. But each of the functions should be addressing certain types of impacts and have certain types of expected benefits. What I have here is I'm going to go through 6 of the more common functions, smart work zone functions that you see out on the road. Several of those are there's examples here in Texas that have been deployed as well as across the country. First one, probably the most common one you hear about is that of queue warning. The intent of this type of technology is to really reduce the frequency and severity of crashes that occur when queues form. I got some data here in a few minutes. I'll show you. I am convinced that the queue formation, the data suggests it as well, are the #1 contributing causes to the work zone safety issues that we have. I don't know if you all saw 2016 data is out as of yesterday. Texas's work zone crash fatality numbers are up 20% from last year, and it's the 3rd year in a row we've seen an increase. They're up nationally. It's a function, I think, of additional work and that kind of stuff, but it just illustrates how much more work we need to do to mitigate those kinds of impacts. So the primary reason of queue warning is for the safety, but if you reduce the number of crashes, obviously you have fewer additional delays generated when that queue or that crash backs up traffic even more, so you have a secondary impact or benefit from delays, and that also then improves productivity. So queue warning is that one. The second one, data travel time provision, where you're just providing, here's the current travel time from point A to point B. You may do it as a comparative travel time, may do it in terms of additional delay. The intent, primarily you're trying to improve customer or reduce that dissatisfaction. By giving them information, data does show that customers understand work zone needs to occur, and they understand that sometimes that creates congestion. What really hacks them off is not telling them about it and what to expect. Because it's like, you knew you were going to do this. Tell me that there's a delay, how long it is, and they really like to know ahead of time. But even right now, they understand that that's not always possible. But if they encounter congestion due to a work zone without any information about it, how long it is, and that kind of thing, really degrades their satisfaction level. So, but so that you're trying to then with travel time, potentially, if you get them to divert, you got reduced demand, reduced delay. So those are the primary reasons you do this. Reduced demand can reduce then the potential for crashes. So there's a secondary potential benefit of fewer crashes, but you're really trying to, again, affect the driver behavior and their customer satisfaction level. Variable speed limits or speed harmonization is another technology that we haven't seen as much, use of across the country. Active traffic management kind of concept deployed in a work zone environment. The harmonization is intended to smooth things so you get less turbulent traffic flow. There's some evidence that says that by doing that, you might get a slight increase in vehicle throughput, so you have both some safety and potentially mobility improvements or through reduced delay, and then that ultimately can contribute to improve contractor efficiency by not blocking their deliveries and that kind of stuff. So this is done both in a regulatory environment which need enabling legislation in most cases, or there have been instances where they're using it in an advisory mode to encourage more smoother speed operation there. So. Y'all have heard, I think, about the dynamic late merge, the zipper merge. That's got a lot of attention in recent weeks. It was picked up a couple of locations here in Texas by the media. It's a concept where you're trying to encourage folks to use all the lanes approaching the merge point when there's a queue there, avoiding that. And it happens mostly in the rural areas, or one lane backs up as soon as they see the lanes closed. And then the few brave, or we think they're jerks, the ones that jump out in the right lane and try to get to the front and then weave their way in, and then you have there's no way I'm letting you in now, I'm there, and all that mess that goes on. The concept here is make everybody, or encourage everybody to use all the lanes, tell them to take turns, and it really, the evidence does suggest that this does work, reduces that length of queue that you might have to protect or try to inform either through advanced signing or through a queue warning system. It also reduces that potential, because all that makes everybody happy, and you don't feel like you're getting cheated by that jerk. So that customer satisfaction is the main reason you're doing it, as well as trying to reduce the potential for those crashes that occur when the person in the closed lane zipping down there at high speed, and somebody pulls out because they don't want to wait in line anymore, and the sights wipe and rear-end crashes occur there. Again, reducing the crashes reduces potentially additional delay generated, so it's a secondary impact as well as that effect on contractor productivity. The next function that we're seeing starting to be looked at a little bit more across the country, that of construction access point warning, and there it's the idea that we're trying to reduce crashes, but we're trying to reduce those that are resulting from speed differentials between construction vehicles entering and exiting the workspace and higher speed traffic in the travel lanes. We see all the data suggests rear-end crashes are the top type of crash that occurs in construction zones. We think it's usually associated with these queues. we've looked at some of the data through some of the national databases and other things. We do see a significant portion of those types of rear-end collisions and sideswipes that you can associate with, cut trucks coming in and out of the workspace. So again, the idea is to detect when they're coming in or out, warning traffic through dynamic message signs of some sort, or flashing signs or that kind of thing. So we've seen a little bit of that here in Texas. That seems to work well anecdotally. So that's I think a thing that's going forward is going to see a little more of going deployment-wise. The last function I want to kind of bring up is that of the maintenance and perhaps enhancement of TMC, Transportation Management Center functionality, and that's where you're maybe going to lose communications. You want to maintain camera ability to monitor conditions. You're going to lose a sign, DMS sign. You're going to provide maybe some DMS or portable change of message functionality. You're doing the same thing that the benefits are to maintain the kinds of benefits you're achieving with a TMC kind of functionality, the detection of incidents, faster response, those kinds of things that reduce the severity of crashes, the delays that result, and again, improves customer satisfaction. So those are the main functions you're going to see or you hear about. And when we talk about smart work zones, and the idea is to match the functions to the potential needs or impacts that you expect. There has been some work in this area trying to quantify these benefits. I've got a listing here. I think Q warnings once received probably at least in recent years, most of the attention. Depending on how you do the analysis and stuff, we see between a 14 and 55% reduction in crashes at work zones where queues are present. So pretty significant. And then those that don't get reduced, because these systems are not 100% effective in reducing all crashes, we do see the crashes that do occur tend to be less severe. We've got some evidence that travel time information, or in some cases providing diversion messages to try to encourage diversion, does work. Depends on each project's going to depend on the roadway network and that kind of a thing, but diversions of up to 20% are not uncommon. We have seen in speed harmonization some evidence of that do reduce that speed variance, which we believe in most cases is associated with the reduced crash potential. Hasn't really been documented in that term just yet, though, in work zones. Zipper merge, we do see that those systems do work. You do get the significant portion of folks that used to join that open lane queue, moving over, staying in the closed lane. That cuts that overall queue length by up to 40%. Studies of the merge point itself show that because nobody's been fighting, nobody feels that they've been cheated, much more cooperative. That little zipper, take your turn, works much better, so you reduce those aggressive merges. We don't know a lot about construction access point warning yet. Just anecdotal evidence that say, yeah, people do tend to react if you put out the right message when there's a truck exiting or entering. And then we do have evidence when you maintain or enhance the TMC functionality that you can get up to, in this one instance, up to a 45% reduction in that response time that they would have had otherwise if they hadn't deployed the system. So again, enough evidence that's why we're looking at these kinds of things. So this is I think important. The challenge that y'all face and we face as well is well, really what you need to do for a particular work zone deployment. You want to do that benefit cost analysis assessment. That is this a project where this technology makes sense? And what you're trying to do is you look at do the sum of the benefits I'm going to achieve during the deployment of this technology functions exceed the cost that it's going to take to deploy it out there. Now, when you talk about that, you got to get beyond just it reduces crashes by 45% or 55%, for example. You got to get at, well, how many times is that going to happen, and then how much equipment do I have to get out, and the cost of that equipment to get such that the frequency of that occurrence offsets that cost. If I'm putting it out for a project, it's going to happen 2 nights or whatever, and it costs me $1 million. It's hard to, that doesn't really justify the cost. But until you go through and sit down and try to apply and figure out how many instances will this type of technology, this functionality, occur, and compare that and try to come up with, at least at a sketch planning level, estimated benefits, compare it to the costs that we're looking at, you really have a hard time justifying and making decisions about deployment. So what I'd like to do just for the last few minutes, give you one example where we've been doing this a little bit, and that's with that Q warning example, and how you go about it. So if you're looking at, hey, should I use Q warning functionality on my project? Well, what do you start with? Well, what kind of things are going to create the queues on my project? Obviously, lane closures. Well, when am I going to have them? How long are they going to be? What kind of impact do I expect queues? Do I expect them to be is it a daytime closure and they're going to be there for the entire duration of the shift? Is it going to be just during peak hours because it's a long-term closure? Are my lane closures not going to be a problem, but because of what I've had to do, it's going to be the peak rush hour that's going to be there? Is it not going to be any of that? It's going to be because I've closed my shoulders. Stalls and crashes that normally got moved to the shoulder are now going to be lane blocking incidents, and that's going to be what's going to generate my queues and problems. So figuring out what that is, how frequently that's going to occur, and then the next steps are pretty straightforward. For each of those incidents, how many crashes do I expect? How much if I put a system out, how much benefit would I get from doing this? And then if I reduce the crashes by this amount, well, what's the economic value of that? So what I've got here, a few slides going forward. The effective queues, I've shown this a few places. I'm not sure if I've shown it here. This is from I-35. We went and looked at lane closures during the nighttime lane closures on I-35 and compared them to normal crash frequencies. When you don't have queues out there and doing the lane closures, crashes tend to be about 8% higher. That's really consistent with the overall numbers about work zone effects nationally and in Texas. If queues are present, they're up by a factor of 5, as you can tell here, up by 500%. Well, actually, it's a factor of 6, and if you do the multiply, tremendous improvement, increase in crashes when queues form. So if using that data, and the fact that queues that form, the severity of the crashes here is likewise. More than half of them, when queues are present, involved injuries or fatalities, compared to about a third of them when there's no queuing present, kind of thing. So that's where you start with. Okay, if I have a queue, I think crash rates are going to go up by that amount on number of crashes. You have to start with a baseline. Here, there's some data out here as far as work zone. And those of you that are familiar with the Highway Safety Manual, the idea of a safety performance function, there's been some recent data that's been put out as a sort of a baseline crash rate that in the absence of queues and lane closures and stuff, you can use that as a starting point, apply those percentage increases that we showed you on the previous slide, start to get at, well, how many additional crashes am I going to likely to experience during that event? Looking at time of day distributions, applying those two together, you can get during the hours that I'm planning to do the work, this is how many additional crashes I'll experience, and do that mathematics there. So effective queue warning systems, I mentioned this came from the I-35 data set. When queue warning systems are deployed, we see a 55% fewer crashes than would have occurred if we hadn't deployed the system based on our analysis methodology. We bring that severity down from 1 out of every 2 crashes involves an injury or fatality down to less than 1 out of 6. So again, those two are the benefits. Take that, apply that, do the math, run the mathematics here, using whatever your choice of economic value of crashes. The top one is from what the Highway Safety Manual shows as a standard economic value. The numbers below are from an FHWA report that came out several years ago trying to quantify economic value of crashes. We do all that, stir it all up and everything. You can get something like this, and this is an estimate of deployment on a per night on I-35. Is nighttime, you'd have to do a little bit different analysis if it was daytime, but as you can tell, depending on the number of hours of queuing, ADT range that you're at, you can achieve between 5, minimal amounts up to, if you look at that upper range, which would be queuing for several hours a night, maybe a full road closure, pushing them off on the front edge of the road around a bridge project or whatever, you can get up easily into the $25,000 per shift benefit in this queue warning systems that then, depending on how many times you have that, compare it back to your costs. So an illustration of the value of going through this and being able to use that to make decisions about whether yes or no on the system, amount of system, equipment, that kind of thing. So that's all I wanted to cover today. My contact information there if you want it. Then I guess we'll take any questions.
Questions from anybody? Yes, sir.
Jerry, did y'all look at any overheight detection since you had that one accident on I-35?
The question is, was any overheight detection looked at based on the accident on I-35?
Let me start with that. Some look into that. I don't think there was a decision made to deploy that. What's been looked at is the need to kind of incorporate information like that into a traveler information database and app that would help inform travelers of that instance. Other states are looking into that. But to my knowledge, no one has actually moved forward on an actual application or inclusion on a project. So,
was that a permit issue where he didn't follow his permitted route?
The question is, was the referred to accident a permit issue? Did he not follow his permitted route?
No, absolutely. I mean, the guy was way over height from what I recall. It wasn't an issue on the part of the department or the contractor. It was just he shouldn't have been on that road and was way over. So.
Yes, sir.
Do you see any reasons why these wouldn't be useful in short-term lane closures? I'll be working on some accelerated bridge construction projects where the lane closure may only be over a weekend, but it's going to impact traffic very heavily.
So the question is has this been looked at in a short-term duration use? For the example given was a bridge project that really was only going to shut down things over the weekend, short duration, but possibly have the benefits.
And I would say the answer to this is yes, certainly has application. Just the numbers, the factor of 5 or 6 if you have a queue there justifies it, or at least makes you think about it. The problem which becomes is paying for it and how you pay for it. On a short duration project that there are typically lower overall cost numbers, it becomes more challenging to do it in a traditional bid item on a project. And what we're seeing, other states, I haven't seen it here, anybody in any of the districts look at this yet, but other states are looking at the idea of, well, let's collectively create an on-call contract that we can then have that contractor justify, or it's basically the subcontractor. He's been guaranteed a certain amount of work over the 2-year period, and we tell him where to go, and it doesn't matter whether it's a maintenance operation for 24 hours, it's a weekend closure. That way you don't have to try to offset the cost just on that one project. You amortize across multiple projects and applications. That's where we're seeing this going for shorter application, at least in other states. And I think that makes a lot more sense than trying to each project having to justify the cost of a system itself. But from the need, I think you're right. Anytime you're going to have queues, I think you should have it. Just figuring out how to pay for it in an efficient way is the challenge. So.